Alright, so in this video I'm going to talk about some properties of logarithms and how to expand and condense logarithmic functions, primarily using the product property, the quotient property, and the product property. So the product property, just as a reminder, tells us that if we have one log base b of x times y, then that can be broken into two logs with that same base b that are added together, log base b of x plus log base b of y. The quotient property tells us that if we have a log base b of x divided by y, it can also be broken into two logs with that same base b, but they're going to be subtracted, log base b of x minus log base b of y. And finally, the product property tells us that anytime I have an exponent, log base b of x to the power of p, I can take this power and I can bring it out front, and it's the same thing as p times log base b of x. So using those, let's see what we can do to either expand, so take one log and break it into as many logs as we can, or condense and take multiple logs that have the same base and try to put them together into one log. So let's look at log 6 times x cubed. Now I see right here that this is multiplication. So the first thing that I'm thinking is that I could use the product property to break this into two separate logs, log of 6 plus log of x cubed, since 6 and x cubed are multiplied together. Okay, so I've broken that up. I can actually keep going. If I look, there's a few more things that I can do. If I look at 6, one thing that I notice is that 6 definitely can be broken into some smaller factors. So I could break 6 into 2 times 3. And once I make it into multiplication like that, again, I can use the product property and separate this into two separate logs, log of 2 plus log of 3, plus I still have my log of x cubed. Alright, we're getting closer. I don't see anything else that I can do with log of 2, and I can't really evaluate that super easily off the top of my head. 10 to the power of something giving me 2, so I'm going to leave that one alone. Same thing with log of 3, but if I look at this last one, I see that I have a power, so I think that I can use the product property right here to move this cubed, this power, out to the front of my log and do 3 times log of x. So let's take log of 2 plus log of 3 plus 3 log of x, and nothing else we can do with that. Okay, next one. Let's see if we can condense this log into one, and by checking they're all ln, which means they're all log with a natural base of e, so I can put them all together if I use my properties correctly. I noticed that all of them also have a number in front, so I'm going to start by using the product property to put my 2 back as an exponent, my 3 as an exponent, and my 1/2. So I have ln of x squared plus ln of y cubed minus ln of z to the 1/2 power. And typically I like to write a power of 1/2 as a root. So I can write this as ln of x squared plus ln of y cubed minus ln of the square root of z, because a power of 1/2 is the same as a square root. Alright, let's see what we can keep putting together. The goal is to get this to 1 log ln at the end. I see addition here, and I have the product property, which tells me that I could put those together into 1 log if I multiply my x squared and my y cubed. So I could have ln of x squared times y cubed minus ln of the square root of z, down to 2 logs now. And I can put these together if I use the quotient property, because subtraction I can write as division. I need to take this whole thing and divide it by everything inside of this second log. So ln of x squared times y cubed divided by the square root of z. And now I have 1 ln, 1 log of all of these things, and I've condensed these logarithms into 1 ln.